moving ahead with the idea of friction, now that we have become aware of what is friction, what are the two types of friction, what is the difference between them, let us examine what causes friction and what kind of factors does friction depend upon. So imagining a surface on which a crate rests, there's a force that's trying to push the crate, and of course there will be friction that is going to prevent the movement. One thing that is obvious is that the materials do matter. So wooden surface, a rough wooden surface on concrete floor is going to have more static friction and dynamic friction uh, rather than, let's say, an aluminum crate lying on a polished marble floor. Um, Simply because it's easier to be able to push a similar a comparable crate made of aluminum on a marble floor than it is to push an crate made of rough wood on concrete floor. So material matters, it seems to be fairly obvious. Very often we would also say the weight would matter. You can imagine that an heavier object would be harder to push than a lighter object. So we'd say that the weight of the object matters. Now, if you think about it a little bit more, you would also think that a larger surface in contact would matter. Because if you look at the surface from the top and you say that, okay, so this is the surface area of the crate, and there is another crate which is larger, uh, and therefore the surface area that is in contact is also going to be larger. So which of these two would have a greater friction? Intuitively, our senses would say that the one with the larger surface area will have greater friction. Um, you kind of imagine it as something that can grip the surface. Okay, so therefore you would say surface area matters. Okay. Now,
Sir,
yeah,
sir,
yeah, yeah.
this book and the what you just said that surface area matters when regarding
No,
friction, right?
no, I didn't say it. I said that that is what you could intuitively arrive at.
Yeah,
You
sir,
just
but
think about it. Yeah.
in the book,
Ah,
the book we read in
yeah.
conceptual physics, it
Yeah.
says that surface area, it only affects the thing as in getting worn out or stuff like that. It doesn't affect friction. It just gets worn out if it's too thin or something.
Yeah. So the thing is, an intuitive answer is based on what you think to be true, um, and that intuition can be verified in different ways. So one way in which you have verified is by saying that a textbook says that, a textbook that you believe, a textbook that you trust, says that surface area does not matter. It only matters in the sense that more surface area will get worn out
Sir, but
if it is.
textbook they must have experimented and then done it, right?
Yeah, correct. I agree with you. So bear with me. What I'm trying to do is,
Okay.
I'm trying to eliminate the ones out of these three factors that I have written down over here that are actually not the factor in deciding friction between any two objects. Okay, so one is that the textbook is saying that, well, surface area does not matter. So the textbook disagrees with surface area.
Yeah.
Okay? If you read a little bit closely and you had watched the video, you will realize that even the weight, that is the mass part of it, does not matter. If you have an
Sir,
object
but
with,
mass part of it does play some amount of role, at least in the.
okay, so wait. So for that, we'll have to look at how to sort of eliminate the ones that do not matter. Okay, one simple approach that we can take, not practically, but theoretically. I mean, as a thought experiment, what we can do is that we can do the following kind of an experiment. This is what Professor Walter Lewin actually does in the experiment in the video also. So he takes a surface with an inclined plane. Okay, and the inclined plane sort of happens to have a protractor on it which can measure the angles, and uh, the upper one, um, this surface can be moved up and down. Are you getting the picture what I'm
Yeah.
talking about?
No.
No.
Yeah,
So,
sir. Yeah, sir. Got
so
it.
there is a
Yeah.
hinge over here.
Oh, like that. Okay.
Okay, and the surface can be moved up and down. The surface, okay, I'll mark them if it's hard to follow what I'm talking about. um, the surface A
You
and the
can open a new
okay,
page.
So we are saying that
hmm.
mass does not matter, the weight matters.
Yes, exactly. The mass does not matter, but the weight matters. But in what sense? We'll also come to
Sir,
that.
but the thing you told us to read, I didn't understand some of it, so I don't really. So you're gonna.
It's okay. I'm explaining them anyway. It's good if you read it, you didn't understand parts of it, and then you attend the class.
Oh.
Right. So you can kind of attempt to figure it out. Okay. So then you place the object for which you want to find out the friction value. Okay. And the other point is the object that is there on top and the surface which is below it, those two must be something specific. So in this case, I'll put it as wood and concrete.
Oh.
Okay, or if you like plastic and concrete or rubber and concrete, let's say it's a sort of a tire company which is attempting to do this. So what I want to do is I want to test out different formulations of the rubber compound that I use for making the tire, right? So let's make this rubber and concrete. Okay. Then what would we do? We would increase the height of the surface A. That is, keep increasing the angle. You get that point?
Yep.
Okay. So let's say that I keep increasing this to the extent where this object would then start sliding.
Sir, then this object will have more friction, right?
No,
It will have
when you
more
say
weight.
wait. When you say more friction than what? We are doing this for the first time.
More, sir. So the small first box you made, A.
Yeah, it's the same box.
It's the same thing.
Yeah, it's the same box, but the incline,
The incline is more, exactly.
yeah. So if the incline is more, that means the friction will also increase.
No, but
Because
we have
this
said
is
that,
at the verge of sliding, sir. That, like you said, static friction is more than the
yeah,
dynamic.
exactly. So,
Friction
so
is
the thing is,
decreasing now.
so okay, wait. I'll introduce a few more things because you have asked this. There is a force that is going to cause it to slide along this direction, correct? You have to think carefully about where that force comes from. I won't explain it now, that we will come to a little bit later. But obviously there is a force that is causing it to slide down.
Gravity?
Yes and no again. So I'll come to that. And there is a force of friction that's going to prevent it.
Okay.
Right? So now when you keep increasing the incline, somehow there comes a point when the force that is trying to make it slide
Overcomes the friction.
overcomes the maximum friction that is possible between these two surfaces. Okay. Now at that point, you stop the incline. Okay. And what you get an angle over here, right? There is a certain angle over here, theta. I'll call it theta, just a symbol.
Okay.
And that angle theta says something about the angle at which these two objects will overcome the maximum static friction that is possible, correct?
Yeah.
Okay, got it. Now what we will do is we want to check whether the weight matters. So what we can do, what should we do? You tell me.
you should experiment with two different weight things.
Exactly. So you just add some weight to this object.
You take identical things and add it.
You don't need to take identical things. I just need to
Or
add.
you can do the same thing in two
And
different
add
planets.
add weights to one of them.
Yeah, and hope that the wood against wood, sorry, the rubber against rubber friction is more than the rubber against the concrete friction.
Yeah.
Otherwise, it will fall off when you are lifting it. But anyway,
So
basic
how
idea
did
is
you? I want to know that how did you come to the conclusion that weight does not matter?
I haven't come to the conclusion yet. I'm doing it now.
Oh.
So I add extra mass to the object and then I lift it. Okay. Now here the thought experiment begins because we can't actually perform this experiment directly. Watch the video. But what happens is that you would expect if the friction would become more because the weight is more, that the object will slide at a greater angle, correct?
Huh?
Yeah.
Slide at a greater
in
angle.
the right box.
If weight affects friction, then friction will increase at weight as weight increases. Therefore, it should slide at the same theta.
No, greater theta if friction increases.
Yeah.
I didn't
I
understand.
understand.
Yeah, even I didn't understand this part.
No, so if the weight increases friction, right? Because you people said friction depends upon, or we agreed to examine whether friction depends upon the weight of the object.
Yeah.
Okay, so by adding an object, by adding the mass to the mass of the object, I have made it heavier, correct?
Yeah.
Now, friction would also have increased, correct?
Yeah.
Okay.
We don't know that yet.
Yeah, we don't know that, but that's our assumption.
We're seeing, yeah.
That's our assumption. So if the friction value increased, that means that the angle at which the object will slide has got to be higher. That is the only part you have to be clear about.
It was Ishan.
Yeah, sir. So, if the greater mass object with the same surface area slides.
No, don't go to surface area. Don't go to surface area. I haven't changed the surface area.
Yeah.
So let's get the mass thing cleared. Okay.
If it slides with a greater theta.
Yeah.
Or
a lesser theta.
A lesser theta.
Then we can say
weight affects friction.
Friction. Okay.
But then,
is that point clear to everybody?
Yeah, sir.
If that doesn't happen, then they are in proportion.
No, then they are independent, not proportion.
Can you repeat?
What are we trying to investigate? First, figure that out.
If mg affects friction.
Correct. Is that clear, first of all?
Yeah.
Now, I am giving you a small thought experiment. I have described two surfaces. One is the B surface, which is just the horizontal. Don't worry about that. I have another surface A on which I place an object. Now, the materials that are in contact are rubber and concrete. Okay. We are trying to check out whether weight, or rather actually specifically speaking it should be mass, but it's okay for the time being, we'll keep it as weight, whether weight has any effect on friction. Our assumption is that if there is more weight, there is more friction, because that's what we seem to think. Now how do we test it out is that place the two surfaces in contact first without the extra weight, raise it to a level, a point where the maximum static friction is overcome by the red arrow, the external force. Somebody said it had the external force was gravity, but I haven't agreed completely to it. But forget about what the external force is. That external force causes the object to slide. That means the maximum static friction value was overcome at that point. So you note down the value theta. Okay, so I'm adding one more step over here. Let us say that that value was 42 degrees. Okay, now what I did was I increased the weight of the object. Same rubber surface, same concrete surface, but this time I doubled the mass, let's say. Okay, it used to weigh 100 grams, now it weighs 200 grams. Now I raise the surface again and I keep an eye on the angle and I wait for the object to slide. If weight affects friction, then the angle theta must be greater than or lesser than, most probably greater than, what it was before. That is, should be greater than 42 degrees.
That's right.
You agree with this?
No,
Yeah.
I
Are
don't
you able
agree.
to follow it so
Wait.
far?
So everything is like gravity is playing a role here. So if the mass is increased, then the same friction will occur when the theta is lesser, right? Because it's greater mass, then gravity will.
Yeah, that's what I agreed with both, but the general sort of assumption in our mind would be that a heavier object more difficult to move, so therefore greater friction. But you can argue this way, what you're saying also.
Okay.
Okay. We need to examine that a little bit closely, but do you understand the general premise of what we are trying to do, the experiments premise? Others, I think Anadya
Sir,
said,
I went to the washroom.
are you?
Sir, no. I got it. I heard most of it. I just came like 2 seconds ago.
Okay.
So basically, we have concluded that weight does not.
No, wait. We haven't concluded that.
Oh,
We
we
are
haven't?
concluding.
No,
Okay, so I just
we are
came.
just saying that this is the argument. Now you have to perform the actual experiment.
Basic.
We can't perform the experiment.
And we can't take a secondary source either, because that is not trustworthy.
Secondary what?
Like you can't take another book or something, you can't see it. You have to conduct it yourself because
Well,
it's
if
not trustworthy.
somebody actually manages to do something, I will be very interested to hear and see what you have done. It's not a very difficult thing to figure out, but there will be some variabilities in performing this experiment. It's if you watch
So
the
can
video.
you like just recap everything you said in the past 5 seconds?
I just did because I have recorded that also. So when you
Sir.
put the video, you recap it.
Okay.
I won't do
I'll
it.
see it.
Okay, that will be a third time then.
Sir,
So,
what you're trying to say is the outcome should be different, right?
the outcome should be different. If friction, if you have increased the weight from 100
the first
to
time.
200 grams, sorry, the mass from 100 grams to 200 grams, and if weight, which is a function of mass, does affect friction, then the theta value should change one way or the other. But the fact of the matter is, it does not change. Okay, no matter how many times you do the experiment, as long as you keep the conditions similar, that is friction, humidity, temperature, blah, blah, blah. And of course, the two surfaces in contact, the theta value will not change by much. Maybe a degree this way or that way, but not more than that. Okay, and that demonstration has been done in that video by Professor Walter Lewin.
Yeah.
So from that we can conclude that mass does not affect the friction between two surfaces. Okay, and exactly the same thing can also be performed with the surface area in contact. So you take one object with a smaller surface area, and you take the same object with a larger surface area, but perhaps with the same mass. What Professor Lewin does is, I'll show you. What he does is that he takes a sort of wooden block like that, and he first slides it on this surface, and then he slides it on this surface. You get the idea?
Yep.
So obviously this surface is larger than this surface. So when you slide the two, if surface area makes a difference, then again the theta value should come out differently. But he shows that the theta value within experimental error, plus or minus 1 degree, okay, within 1 degree error, it works out to be exactly the same. So therefore, we come to the understanding, or if you look at the experiment, the conclusion that weight or the mass of the objects and the surface area actually counterintuitively do not matter. So what is the only thing that matters? The materials that are in contact. Okay, so that is one very non-intuitive thing about friction between two surfaces, that it is just the material and the material alone that matters. Do other factors not affect? For example, I did mention that humidity, okay, um, can change friction values by quite a lot. That's true. But you see, again, what is humidity? Basically, that is moisture content in the air, right? And moisture content in the air can condense on surfaces. So if there is higher humidity, then the amount of condensation that is taking place on any surface, right, is going to become more.
Does that also mean temperature?
Well, temperature affects humidity, or
Yeah.
temperature can affect humidity, and humidity can change the nature of the materials in contact. So in that way, it is again coming back to material only. All right. And
When
and for this, that's my house. And for these reasons, it is very hard to do experiments on uh, these materials in terms of friction. Just one moment. Okay. So I hope that kind of makes
Yeah.
this clear. What friction depends upon doesn't depend
wait,
upon.
wait. So when did we prove that weight is not a factor?
Mass is not a factor.
Yeah, mass is not a
Yeah.
factor.
Okay. So that's why I had put a dot on the mass part of it. Weight, however, does matter in terms of the normal reaction force that the surface gives to the object. But I don't want to sort of go into that area right now. Those who are interested, of course, can watch the video to figure that one out.
So what did you put the cross for? Weight or mass?
That's for mass.
Okay.
So maybe what I should do is I should change that and make it into mass.
So can we go? Like,
So weight matters, right?
Uh,
If it didn't matter, we could push a light crate as easily as we could push a heavy crate, right?
One moment.